Hi class. So this is the first lecture video for Math 1240 Statistics. Um, we're going to start chapter 1, which is called data collection. So a lot of this chapter you'll find is a lot of like terminology and just being familiar with terms that we use in statistics, and then also laying a foundation of some different types of studies, different different ways to collect data, just different things like that, to lay, like I said, lay a foundation so we can begin doing some more calculation type things later on in the course. So section 1.1 is titled Introduction to the Practice of Statistics. Objective 1, we want to be able to define what statistics is, and then also think about some statistical thinking. So you can see here that we have first the definition of statistics, which is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusions. Right? So statistics rests on two major concepts. So one of them is data. Oops. Sorry about that. And the other is variation. Right. So these things are super important for statistics, right? We'll talk about those, and along with data. I guess with this, we should emphasize context. Right? I'll just put that in parentheses, right? Because data essentially is, it's not just a number. Like a statistic is not just a number. It's a number with context, and we'll talk about that in a little bit, right? But data doesn't have to be a number. It can also be what we call qualitative. So, for example, like gender is data, right? What gender you are, so that's not necessarily like a number, but so I'm just putting there that context is very important, right? So then I define a couple other things here. So variables are the characteristics of the individuals within the population. Data is information that describes characteristics of an individual. And then another key point is that variables vary, right? So, here I'm just putting out a scenario. If we just consider the variable height, if all individuals have the same height, then obtaining the height of one individual would be sufficient in knowing the heights of all individuals, right? So if everyone had the same height, I wouldn't need to study that, right? I would know everyone has the same height. But that's not the case, right? We have lots of different heights, for everyone. And so as researchers, we might want to try to identify the factors that influence that variability, right? So statistics is really curious about how things are different from one another, right? So we're really interested in variation, right? So if you don't have variation, you can't really do statistics on it, right? All right. So some things that I want to write here off to the side. One is concerning data. So I said this maybe as words, but let me write this down formally. So data can be numerical. So an example of that would be like height. And then also it could be non-numerical. Such as gender. Yeah. So then you can see here the next bullet point I have, statistics are more than just numbers. Context is key, right? So for example, if I wrote down just this list of numbers like 8.32, 7.91, 9.64, 10.33. Some questions that might come to mind if I just gave you these numbers, or what are these numbers, right? Maybe they're birth weights of newborns. Maybe they're there are millions of people. That is the units for this. We have no idea, right? We don't know anything about them. We don't know how they are measured, what units they are, what kind of subjects are they trying to study. Like, we have no information about these numbers, right? So, that's an important thing in statistics, is we're going to basically use some techniques trying to tell a story, be like a detective, tell a story, what the numbers can tell us. And if we don't have that context, it's really hard to do that job, right? So that's real important. So context is key, right? So let me just highlight that. All right, so that's super important. And the next thing is variation is key, right? So, we talked about this a little bit, but if you think about this for a moment, things just naturally vary. Like, for example, if I ask you to write down your name 5 times, right? So if you just pause this video really quick and write down your name 5 times on your notes on a piece of paper, right? And I can do that here. Oops, I'll just write down Tyler. Right, and you can see, for the most part, my name looks fairly similar, but things vary, right? So, like, something that sticks out is, like, if you look at, like, my E, and R here at the last. Oops, let me actually just get a different color. Right, so, like, if I compare, like, looking at these E's and R's, just the last 2 letters of my name, I can tell that those vary quite a bit, right? So those aren't going to be the same every time, right? That's just one example to convince you, that variation just naturally happens, right? Not everything happens the same every time. Also, if you think about like driving to campus today, or if you didn't drive to campus today, maybe you're taking my class online. Just if you drove anywhere, the houses that you pass, they all are going to vary, right? Not everything's the same, right? So that's just another example of variation, right? Things are going to differ, right? So then, just so we can kind of pull apart that statistics definition a little more to understand it, I have looking at the statistics definition in 4 parts. So there's really 4 main parts of the definition. So the first part is essentially collection of information. The second part is organization. And summarization. Of information. The third part is analyzing, right? So information is analyzed to draw conclusions or answer specific questions. And lastly, number 4, we have that results should be reported. Oops. Hang on a minute, sorry. My drawing monitor turned off. There we go. So results should be reported using some measure All right, sorry about that. I had some technical trouble with my drawing monitor. So I think I have a solution. We'll see if this works. So it kept shutting off. So we were looking at statistics definition of 4 parts. The last part, so results should be reported using some measure that represents how convinced that we are that our conclusions reflect reality. Right? So these kind of break down, like different parts of statistics, right? First, we need to collect the information, and then how we collect that information can actually influence the other parts, right? So we can look at, different ways to collect information and how, maybe there might be some what we call a statistical bias present. And then after we have this information, we need to be able to organize it and summarize the information, basically doing descriptive statistics. And then we can take the information, analyze it more, maybe doing like inferential statistics, and then we report our results, right? So that's kind of like the big parts, and you'll see we're going to look at in a little bit, look at those basic ideas of a statistical study in these parts I just mentioned. So another thing I want to talk about is how are mathematics and statistics different? Right, so a lot of people, maybe think they're similar, and they are in some ways, right? Statistics uses the language of mathematics, but really statistics is big enough to be in a field in itself, right? We can, statistics could be thought of as like a subfield of math. So just like, maybe some subfields of science, for example, or like biology and chemistry and so forth. And then even inside of those, there's maybe even some smaller like subfields, right? So maybe you're a biologist, but you specialize in, the parts of the brain or something, right? So maybe you can specialize even further, right? So one thing that sticks out to me, some differences between math and statistics, is really what we kind of talked about on page 1, which when we define what a variable is, right? So if we look up here, remember a variable, so let me just highlight this, variables. So variables in statistics are the characteristics of the individuals within a population, right? That's how we define that, right? So I think maybe I'm just going to come off to the right of the page and make these known. So we have math. We're comparing that with statistics. Right? So one difference, as I mentioned, is how we use the term variables, right? So a variable in math is, like a symbol. Oops. Or a letter. Right? So for example, X, right? X, Y, P, Q, right? So forth. Or we might even use Greek symbols, right? Beta could be a variable. And then in statistics, we said that a variable is essentially like a characteristic right? So maybe like height as an example, or maybe the credit hours earned. For college students is another variable, right? So these are just some examples, right? So even just variable, which seems like a very foundational item, is very different between the two, right? So some other differences is that in mathematics, if I ask you, let's say I give you an example and I tell you to, solve 5x plus 7 equals 10, right? Then, you're going to subtract 7 from both sides. And you get, 5x equals 3. And then now we would divide both sides by 5. And we come up with, x equals 3/5, right? So granted that you're solving this correctly, 100% of the time this is going to be the correct answer. So we're 100% certain that this is the answer, right? Right. So an example problem in statistics, though, might be we want to estimate the average commute time for MTC students. Right? And if I asked you for an assignment to solve this problem, right, to come up with this estimate, all of you are going to get slightly different results, right? How you would answer this is you'd want to come up with a sample of students, and from that sample, you would get what's called a point estimate, right? You would get a statistic to try to estimate that average commute time, right? But as you can imagine, different people are going to sample, different students are going to sample, have different people in their sample. So that's going to provide you with a different mean, right? So in other words, there's a variability in answers, right? And we haven't, looked at like confidence intervals or, anything yet. We'll be able to look at those, towards the end of the semester. But just to give you an example, like an example solution, we might say something like, we're 95% confident that the average commute time for MTC students is between 20 and 23 minutes. Right? So notice we're able to, have what we call like a confidence interval. We're, 95% confident that we get somewhere in between these two values would be the true average commute time, the true mean, right? But we don't know for certain. And something we're going to look at, the reason why we kind of have this range of values in statistics is it's really difficult to actually get the data values for every subject that you're trying to study, right? So for everyone in the population, and we'll define some of those terms. All right. So now that you know that math is not statistics, statistics is not math, but they do have some similarities, but they are not the same, right? They are different. All right. So the next thing I have here is just some discussion. So I'm recording this video for my online class, but this is something we might talk about in class, right? If you're in class, is just asking, maybe what are some data that you've seen recently, right? Maybe in newspapers or social media or on the television or on billboards, right? Maybe what kind of data do you keep track of about your own life or your family, right? So, maybe some data that you're seeing. So I'm recording this, we're nearing a presidential election, right? So, naturally there's a lot of data kind of thrown at you for various reasons during that time, right? So you might see something like that, or maybe you're watching television and you see an ad like 4 out of 5 dentists prefer this specific toothpaste or things of that nature, right? So the point here is that data is kind of all around us, right? So after this class, hopefully you'll be able to ask good questions and kind of understand some things about data that can help you with all this information, become a little more statistical literate. So objective 2, we want to explain the process of statistics. So I mentioned that we would talk about this next. So for most studies, it is unreasonable to be able to access all the individuals of interest in your study, right? So that makes sense, right? So for example, if I wanted to, even something as small as all Marian Tech students, let's say I wanted to figure out the average height for all male Marian Tech students, right? As you could imagine, not all male Marian Tech students, might respond to my survey or let me measure them, or I might have trouble tracking everyone down, right? So just logistically, it's not really practical to get measurements from every single person in what we call the population, right? And that's the first term here, right? Population. So population is the entire group to be studied. So then the next term to look at is an individual, right? So an individual is a person or object that is a member of the population being studied, right? So an individual is maybe a person or some kind of object that's in the population. And then a sample is a subset of the population, right? So when we collect samples in statistics to estimate what we're trying to estimate for the population, right? So I have a figure, it says see figure 1. I have that, I think, on the next page here off to the side, right? So this is figure 1 in the textbook. So this is just trying to give you an idea, if this is my population, so this is everyone that I'm studying, then a sample is, picking some people out of here, a subset. So in other words, everyone in the sample is in the population, right? But so we have some kind of subset here, right? So for example, this girl, we got this guy and this orange shirt guy, and then we got this lady in the blue shirt, and then this guy in the green shirt, right? All those people that I put circles on their faces, you can see where they appear in the sample, right? But then you notice this individual guy here is not in the sample, but he is in the population, which is here, right? But he did not appear in the sample, right? But an individual could be in the sample, but the reason why they probably chose that is just to emphasize that the individual is just someone from the population. They don't necessarily have to be in the sample that we're studying, right? So that's the general idea, right? We have some population. I take some people from the population to look at further and try to answer some questions about, right? So then the next definition here is what a statistic is. So a statistic is a numerical summary of a sample. So an easy way to remember is that statistics are about samples. Their S's go together, right? So that's important to note, is statistic, sample, right? And then another term here is descriptive statistics. So I used this term earlier. So descriptive statistics consists of organizing and summarizing data. Descriptive statistics describe data through numerical summaries, tables, and graphs, right? So we're going to look at descriptive statistics for roughly about the first half of the course, right? So This is what we're going to look at for the first half, roughly. And then inferential statistics is next. That uses methods that take a result from a sample, extend it to the population, and measure the reliability of the result. So like before, we talked about confidence intervals a little bit. So like the 95% confident that Marion Tech student commute time is between 20 and 23 minutes. That's an example of inferential statistics, right? So we're going to talk about that. That'll show up roughly in this, basically the second half of the course, right? It's not actually cut in half, but just about, right? And then the last thing we talk about as a parameter is a numerical summary of a population, right? So a parameter deals with population. So let me just make a note of that, right? So we have parameter, population, right? So it's important to remember that population is a measurement of the population, or parameter is a measure of the population, and statistic is a measurement of the sample. So easy way to remember that, right, is notice their first letters go together, right? So S in sample matches with S in statistic, P in parameter matches with P in population, right? So that's an easy way to remember that. So you want to make sure you know that. So when looking at statistical study, we often look at descriptives first, and then look at doing some inference. So that's kind of naturally why that's the order we cover in class, right? So descriptives kind of help build a foundation so we can do inference later, right? All right, so now I have an example. So example 1 says, for each statistical study described below, identify the parameter and the statistic in the study. Right? So part A, we have a nutritionist wants to estimate the mean amount of sodium consumed by children under the age of 10. From a random sample of 75 children under the age of 10, the nutritionist obtains a sample mean of 2,993 milligrams of sodium consumed. Right? So the parameter is the mean amount of sodium consumed by children under the age of 10. Right? So the parameter, remember, goes about the population. That's what we're trying to answer. That's what we want to know. So again, it's impossible to measure everyone in the population. So we get a sample, in other words, a statistic, to try to estimate what the parameter might be. Right? So the statistic here would be the mean of 2,993 milligrams oops there we go, sorry. So my monitor turned off again. Sorry about that. So the mean of 2,993 milligrams of sodium obtained from the sample of 75 children. Right, so the next one, part B, an energy official wants to estimate the average oil output per well in the United States from a random sample of 50 wells throughout the United States. The official obtains a sample mean of 10.7 barrels per day. Right, so the parameter would be the average oil output per well in the U.S. The statistic would be the mean oil output of 10.7 barrels per day from the sample of 50 wells. Right. So then part C, the last one, we have an education official wants to estimate the proportion of adults age 18 or older who had read at least one book during the previous year. A random sample of 1,006 adults age 18 or older is obtained, and 835 of those adults had read at least one book during the previous year. Right. So again, we have a parameter, which in this case would be the proportion of adults 18 or older who read a book in the previous year. And then the statistic, so this is the sample, right? That was, 835 out of 1,006 total people in the random sample, which gives me a proportion of 0.830. And that is the proportion who read a book in the sample. All right. Perfect. So then in the process of statistics, we want to do four main things. Number one, we want to identify the research objective. So you can see, a researcher must determine the questions he or she wants answered. The questions must clearly identify the population that is to be studied, right? So that's, one of the first process in statistics. Next, we want to collect the data needed to answer the questions, right? So, conducting research on an entire population is often difficult and expensive. So again, we typically look at a sample, right? This step is vital to the statistical process because if the data are not collected correctly, the conclusions drawn are meaningless. Do not overlook the importance of appropriate data collection. So we're going to discuss this step more in sections 1.2 through 1.6. So really the rest of chapter 1. Right? And then from there, we're going to look at how to describe the data. And we're going to look at this in detail in chapters 2 through 4. So we have here descriptive statistics allow the researchers to obtain an overview of the data and can help determine the type of statistical methods the researcher should use. Right, so there's our descriptive statistics. Then from there, lastly, what we want to do is perform the inference, like the confidence intervals, right, which we're going to look at, near the later part of the course. So we're only going to go up through chapter 10. So we're going to look at this, mainly in chapters 9 and 10. We'll look at methods of inference, and then you can see here chapters 5 through 8. We'll also discuss techniques for measuring reliability, right? So that has to do with this. So with this, we want to be able to apply the appropriate techniques to extend the results obtained from the sample to the population and report a level of reliability of the results, right? So again, the whole idea of statistics is that we want to know the parameter. We want to know the value for the population, right? So we can't collect everyone, so we gather a sample. We collect a statistic, and then we use that information to try to estimate what the parameter would be, right? That's essentially the overview, right? So in order to, practice this, I have an example too. Here you could pause the video now and read over this example 2 problem, and then instead of reading that to you, I'm just going to jump in and answer these questions, right? I think mainly I'll mainly highlight, because really the answers are just highlighting. So again, go ahead and pause the video and read over the paragraph for example 2, and then I'll go over the answers. Right. All right. So after reading that, you should have read this little blurb about a statistical study that was done. So for number 1, identifying the research objective, I think I'm going to highlight this in yellow. Right. So identify the research objective. That is basically this part. Right. So I have to determine the association between start time of school and sleep duration. Right. So what's in yellow is the research objective. Let's see what's another color I can get here for the highlighter. Let's do green. Right, so question 2, all highlighted in green. So it says, collect the information needed to answer the questions. So essentially, this next sentence answers that. Right, so the researchers studied 383 randomly selected adolescents from the United States, right, is what I had written for number 2, right? So then number 3, we want to describe the data, organize and summarize the information. So I'll highlight this in blue, like this aqua color, I guess. I already did blue, so yeah, I'll just call that aqua. All right, so basically all of this students who started, oops. There, so basically all that part goes with number 3, right? So I had written down the adolescents had a mean age of 15.5 years with a standard deviation of 0.6 years. Students who started school at 8:30 a.m. or later exhibited a significantly longer sleep duration of 27.5 minutes. Further comparisons showed that every 1 hour delay in start time was significantly associated with 21 minutes longer sleep duration. Right. And then lastly, draw conclusions from the data. So I'll do like this pink color. So conclusions is basically just that last sentence, right? All right, so there's some practice of that. So now what I want to look at is an inference example. And again, we're going to go over like confidence intervals much later in the course. But, like in the homework question, there's maybe a mention of this. So I just maybe want to practice this a little bit. So I have here just that statistical inference is a big part of statistics that we will mostly study in the second half of the semester. It is mainly a theory, method, practice to form judgments about a parameter based on a statistic with some level of confidence. Let us practice interpreting something called a confidence interval for now. right? So we have here that the hospital reported that all car crash victims pay an average of $9,004 in hospital bills with a margin of error of $266 and a 95% confidence level, right? So mainly, all I want you to be thinking about now is that we have this statistic value that we calculated from a sample, and this margin of error, essentially you add and subtract to this value, right? And this is going to give us what we call a confidence interval, right, with that specific level of confidence, right? So if you take 9,004 plus or minus 266, what you'll get is the interval 8,738, right? So that's found by taking 9,004 minus 266, and then if you add 266 to it, you should get 9,270, right? So we get these two values. And I guess really I don't need those commas here, so it makes that a little less confusing, right? So then what we could say is that the hospital is 95% confident that the mean hospital bill from car crash victims is between $8,738 and $9,270. Right? So again, look at this later. I just need you to be able to go from basically from this statement and be able to identify this statement as a multiple choice, right? So that's all I'm really looking for, that you can really add, subtract, and understand that we're 95% confident, right? All right, so the next objective is being able to distinguish between what we call qualitative and quantitative variables. So qualitative variables, or sometimes referred to as categorical variables, allow for a classification of individuals based on some attribute or characteristic, where a quantitative variable provides a numerical measure of individuals. The values of a quantitative variable can be added or subtracted and provide meaningful results. Right. So basically what you want to think about is the variable like putting people into groups, or is it some kind of measurement that we have taken, right? So that's an easy way to remember this. So in other words, qualitative, think of, you're putting into groups, where quantitative is a measurement, right? So qualitative are also called categorical variables. Quantitative variables are also called numerical variables. Right? So then for example 3, we want to classify each of the following variables as qualitative or quantitative. So one is the color of automobiles on a used car lot, right? So that's a quality, right? So we would mark qualitative. Oops, I wanted to pick yellow. Right, so the number on the jerseys of a travel baseball team, right? So something you want to be careful is just because something's a number does not mean that it's numerical or quantitative, right? So you want to think about, is the number a measurement? So the numbers on the jerseys of a travel baseball team. One question that you can kind of ask yourself that doesn't always work is, does it make sense to add or subtract these, right? The answer would be no, right? If I just add jersey numbers together, that's kind of silly, right? So if you really think about it, the jersey number is essentially a number that identifies who the player is, right? So this would be qualitative, right? It's putting people into groups, if you will, right? It's not a measurement. The number of seats in a movie theater, right? So that is a measurement, right? So that would be quantitative, right? D, a list of house numbers on your street, right? So again, just because something's a number doesn't mean it's quantitative. So a house number is basically identifying whose house you're talking about, right? That's qualitative. It's not a measurement, right? We're not using anything to measure or count anything, right? Also maybe again a test that can work most of the time is, doesn't make sense to add house numbers together. No, not really, right? Also phone numbers, right? Phone numbers don't make sense to add up. Social Security numbers, they don't make sense to add those up, right? Those are all qualitative variables. E, we have the ages of a sample of 350 employees of a large hospital, right? So that would be quantitative, right? We're counting or measuring, right? So you want to get some practice with that. Right. So then example 4 says the data below was collected in an introductory statistics course. Use this data to answer the following questions. Show all of your work legibly. Whoops, I copied this out of an old assignment. We don't need that, right? So you don't need this part, right? Well, I guess that could be in directions, but this is not for points. All right, so I have some notes here that we're going to discuss. One is the stacked versus an unstacked format, right? So if I go to the next page, you'll notice that this information in this table is organized in a way that each row, so each row is a person or an individual, right? And each column, right? All these columns are variables, right? So this is what we call a stacked format, right? For storing your data, right? Everything is stacked on top of each other, right? So you have like person 1, and then below that's person 2, right? All the people are stacked on top of each other, right? So the kind of the opposite of that, right, would be like unstacked, right? So what would it look like? What unstacked data set look like, right? So with an unstacked data format, really you can only retain like 2 variables at most, right? So maybe I want to look at gender, so I basically make like a table, and we'll say male and female, and then so I want to retain the variables gender, and we'll say the math ACT, right? And really gender, this is the variable female, right, from the data, from the stacked data set, right, this female column here, right? But something you'll notice is we have 1s and 0s in for the female, right? You might be thinking, what does that mean, right? So that's kind of like my second bullet point, is that we can code variables, right? So one common option is using binary, right? So 1 and 0. So 1 typically means true, yes, and 0 typically means false, no, right? So if my variable is named female, essentially what that means is that 1 would be yes, that they are a female, and 0 would mean that they're male, right? In other words, they're no to female, which means you're male, right? If you're just thinking about those 2 options for gender, right? You'll also notice that the variable first semester is coded, right? So 1 would mean yes is my first semester, and 0 would mean no, right? So this is a common method used in statistics, is to code your variable, your information, right? So then, what I'm focusing in on is the variable female and math ACT. So what we'd have to do is go through and look at this first person is a female, and they have a 20 on the math ACT, right? So that would be listed here. Whoops, I want to write the pen. There we go. So I would put 20 here, right? And then if we look at the next one, so that's a 1, so it's a female, and she got a 17 on her math ACT. So we would write 17 under the female list, right? And then you would go down, the next row is a 0, which means it's a male, and you get a 19, right? So you would have to go through all of these to transfer those variables into a stacked format, right? So I'm just going to do this kind of quickly. So you'd have 19, 20, 23, 34, 19, and then 17, right, for the males. For females, the ACT scores are 20, 17, 21, 25, 19, 20, 21, right? So this is unstacked format, right? So you'll notice that the unstacked format really isn't very useful, right? And also it's kind of annoying because you're limited with the number of variables that you can have, right? So a big pro to storing things in the stacked format is I can add more people and more variables pretty easily, and I can kind of have as many of those as I would like, right? So then maybe something else to kind of talk about here is Excel. So you'll notice this, looks like a spreadsheet, and a very common software used for spreadsheets would be Microsoft Excel. So Microsoft Excel works really nicely to kind of store and organize our variables. It also makes it easy to sort. So if I wanted to, sort, maybe tallest to smallest in height here, I could do that pretty easily in Excel. Right. But you'll find though that we don't often use Excel to do a lot of statistics with, right? At least statisticians don't, because there are some problems, some errors with using Excel. So I'll expose you to something called R, which is a free statistical package software that we'll use in the semester. So before we get to there, let's answer these questions. So for part A is how many variables are there, right? So if I want to figure out how many variables there are, I'm essentially counting the columns, right? So all of these headings, let me go ahead and just erase this here. Right? So all of these headings at the top are the variables, right? So there's 1, 2, 3, 4, 5, 6, 7 variables for these individuals, right? And notice this ID number is generic, but maybe it's social security number, maybe it's your student ID number, right? So you're essentially just assigning a number instead of writing someone's name, right? You're assigning a number to each person. So that's a characteristic about them, right? So then part B is how many people were surveyed. So what you'd want to do is count the number of rows that you have, right? Because each row is a person. So the nice thing about the ID variable is it kind of counts how many people you have. So there are 13 people that were surveyed. Next is the variable female numerical or categorical, right? So female, even though there are numbers listed here, this is categorical or qualitative, right? And we're asked to explain, right? So the variable's coded, but the numbers categorize the individual, right? It's not a measurement. So that's why, the variable is categorical or qualitative. And then if we look at age, notice here these are, just values listed here. Is the variable age numerical or categorical? Explain. So this would be numerical or quantitative. Right? So explaining that, it's age in years, it's a measurement, right? But something to keep in, maybe keep in the back of your mind is that age could be categorical, but if we look at how it's stored, it's a specific number of how old someone is, right? But maybe I for some reason wanted to put my people I'm studying, my students, into categories, right? One way to put them in categories is I could organize by age, right? So maybe the variable I just call, I don't know, age 2 or something, right? I mean, I could, make up another variable if I wanted. But maybe I categorize these where I don't know, maybe 1 equals that you're less than 18, and 2 means that you're 18, and 3 means that you're 19 or greater, right? So I could come through and I'd have 1, 3, 2, 2, 3, 3, 3, 3, 3, 3, 3, 1, 2, right? So I just went through really quick and identified the 1, 2s, and 3s for each person. And so now this age variable would actually be categorical or qualitative, right? So just something to keep in mind. It's important to physically look at what the numbers represent. All right, so objective 4 is to distinguish between discrete and continuous variables. So we have here discrete variable as a quantitative variable that either has a finite number of possible values or a countable number of possible values. The term countable means that the values result from counting, such as 0, 1, 2, 3, and so on. A discrete variable cannot take on every possible value between any two possible values, right? So a continuous variable, though, is a quantitative variable that has an infinite number of possible values that are not countable. A continuous variable may take on every possible value between any two values, right? So I have a nice figure here, figure 2 from the textbook, that just shows you, that we have qualitative variables and then quantitative variables. And then if we have something that's quantitative, it's either going to be discrete or continuous. So kind of how I think about these is I think about discrete as a set of stairs, right? So this would be discrete. And I think about continuous as like a ramp. Right? So with discrete, you can't have a value in between, right? So let's say you're trying to count, I don't know how many kids you have, right? If you're trying to count how many kids you have, maybe 0 kids, 1 kids, 2, 3, 4, etc., right? 5. You can't have in between. I can't have 3.26 kids, right? So that would be an example of a discrete variable. Where continuous is, you can have, lots of time in between, right? So for example, age, maybe age of one of your kids could be a continuous variable, right? So you can be like 13.125 years old, right? That's possible. You don't go from 12 years old to the next day you're suddenly, 13 years old, right? There's values in between, right? So maybe that helps. So I have an example here to kind of look at this a little more. So we're just trying to determine whether each of the given values are discrete or continuous. So we have the Honda Civic has 4 cylinders, right? So again, just try to ask yourself, if I have another cylinder, that gets me to 5. Can I have something in between? Can I have like 4.36 cylinders? The answer is no, right? So that's discrete, right? George Washington was 188 centimeters tall, right? So if someone grows, do they just go from 188 centimeters straight to 189? Or is there room in between that they're growing, right? And the answer is yes, right? So that's continuous. So measuring someone's height is continuous. You don't go from one step to the next step, right? There's room in between. The next one, so currently the House of Representatives has 435 members, right? So again, you don't really have like partial of a member, so that would be an example of discrete, right? So you go like 435 up to 436. So you're like counting things, right? That's essentially counting is discrete, right? That's what that was in the definition. D, a female student has an arm circumference of 27.5 centimeters, right? So that's continuous. So similar to like height, right? There's lots of room in between, right? And then earthquake had a measurement of 0.70 on the Richter scale. So that turns out to be continuous, right? So you might need to maybe review what the Richter scale is, but it's a continuous measurement. Right. So just another example why context is important, right? So if you're doing statistics like on Richter scale or a specific topic, you might need to become familiar with that topic a little bit to understand, understand what's going on a little more, right? All right. So then the last objective in this section is determining what's called the level of measure of a variable, right? So there's 4 levels of measure. So we have a nominal level of measure, an ordinal level of measure, interval level of measure, and also a ratio level of measure, right? So I'll let you go ahead and pause the video and read over those 4 definitions. And then I'll come down here and go over this table that I made. So this table gives a brief description and also some examples of those. And I want to write off to the side, right? So we talked about qualitative and quantitative variables before. So it turns out that these 2 levels of measure at the bottom are associated with qualitative variables. And then the top 2 are with quantitative variables. So you want to understand the differences between them. So nominal and ordinal, I think, is pretty easy to understand and remember the difference. Ordinal, think order, right? So ordinal, an ordinal variable, things can be arranged in order. Order makes sense, right? However, with nominal, there's no order, right? So really the difference between nominal and ordinal. So if you have a qualitative situation, ask yourself, does order make sense here? If it does, it's ordinal. If it doesn't, it's nominal, right? Not too crazy. Now, understanding the difference between ratio and interval might be a little harder. So ratio has what we call a natural zero, and also ratios are meaningful, right? Where an interval is we have a quantitative situation, but there's no natural zero and ratios are meaningless, right? So if we look at some examples, a ratio, one is height, right? So if I measure the height of someone, there's a natural zero. If you are 0 inches tall, it means that you have no height, right? Also, ratios make sense. If someone is 3 feet tall, another person is 6 feet tall, we can have a ratio of the two. The person that's 6 feet tall is twice as tall as the person that is 3 feet tall, right? So ratios make sense. Where if we have something like measuring your body temperature in degrees Fahrenheit, there is no natural zero for degrees Fahrenheit, right? If you are somewhere and let's say it's 0 degrees Fahrenheit outside, that does not mean there is no heat, right? Essentially, temperature is a measurement of how much heat there is, right? So 0 degrees does not mean that there's no heat outside. So there's no natural zero, right, with body temperature, right? It's just one example. Notice there's another temperature system called Kelvin that's not listed here, and there's a reason for that. But I won't go in that depth. But if you may or may not be familiar with measuring something in Kelvin, right? So if you have trouble understanding the difference between ratio and interval, don't worry, you're not alone. So I have here, this is taken from, this table is just, to kind of help you understand the differences between the two. So I recommend that you read over that, the ratio test and the true zero, right? So that can help you understand the difference between those two. And then this next chart just kind of goes through the levels of measurement and how it's kind of like walking upstairs, right? You're getting like more, maybe like a higher level of measurement, right? So nominal is considered like the lowest level, and ratio is like the highest level of measurement. So then I have a statement: when we are applying statistics to real problems, the level of measurement of the data helps us decide which procedure to use. All right, so that's important. So then this last thing I have, example 5, is being able to identify the data set's level of measurement: nominal, ordinal, interval, or ratio. Right. So I have a lot of examples of practice with this because I know it's maybe a little hard, or not something you're used to doing, right? So the first one we have here is hair color of women on a high school tennis team. So the first thing you want to ask yourself, is that qualitative or quantitative? So that is qualitative, right? So our options are, nominal or ordinal. So then the next question you kind of ask yourself is, does order make sense here? And no, right? If you have blue hair or brown hair, it doesn't mean, one's better than the other, right? There's no order. So this would be nominal. Right? Part B, the numbers on the shirts of a girls' soccer team. So again, this is qualitative. So this would be nominal or ordinal, and the order doesn't make sense, right? If your jersey number is 2 or 5, there's no. I mean, if we just talk about those numbers in general, we have an order, right? 5 is greater than 2, but just because your jersey number is number 5 doesn't mean that you're a better player, or it doesn't mean anything in particular, right? So that would be considered nominal. Ages of students in a statistics class. So that is a quantitative measure. So you want to think about, is it ratio or interval? So do we have a natural zero? And also, do ratios make sense? And the answer to both of those is yes. If your age is 0, it means that you have no age, right? So this would be a ratio. Part D, temperatures of 22 selected refrigerators measured in degrees Fahrenheit. So this was actually one of the examples in the chart. That's an interval. Right? So again, the way to think about that is it's quantitative, so we know it's either interval or ratio. And there is no true zero in degrees Fahrenheit. Remember, 0 degrees Fahrenheit does not mean you have no heat. So that is why it's interval. Part E, the number of milligrams of tar in 28 cigarettes. Right? That is a quantitative variable. And there is a natural zero, and ratios are meaningful. So that would be a ratio. F, the number of pages in your statistics book. That is also a ratio. Right? That's a quantitative variable. There is a natural zero, and ratios are meaningful. Right? If you have 0 pages in a book, it means that you have no pages. Right? G, marriage status of the faculty at the local community college. So that's a qualitative measurement. And order doesn't make sense here, right? If you're married or unmarried or divorced or widowed or whatever your marriage status might be, it doesn't mean you have any kind of order to that. So that would be nominal. H, we have a list of 1,247 Social Security numbers. So Social Security numbers are actually qualitative, right? They're categorical. So that would be, nominal or ordinal. And then you want to think about, does order make a difference here? And no, right? just because your social security number is maybe a higher number than someone else's doesn't, have any kind of relevance really, right? So that would be nominal. We have I, so the ratings of a movie ranging from poor to good to excellent. So that's qualitative. And order does make sense, right? An excellent movie is better than a poor movie, right? So that would be ordinal. J, the final grades A, B, C, D, F for students in a chemistry class. So letter grades are qualitative. And order does matter here, right? If you have an A grade, that's better than a D grade, right? So this would also be ordinal. K. We have the annual salaries for all teachers in Utah. So that is quantitative. And, we do have a natural zero, and ratios make sense here. So this would be a ratio. Right. The next is list of zip codes for Chicago. So zip codes are qualitative. So this would be nominal. Right, because there's, I should have mentioned, it's nominal because there's no order. Right, order doesn't make sense. If you have a higher zip code, it doesn't necessarily mean anything. M, the nationality is listed in a recent survey. So your nationality is qualitative. Order doesn't apply here, right? Doesn't make sense. So this is nominal. N, the amount of fat in grams in 44 cookies. So that is quantitative. And true zero and ratios are meaningful. So this is a ratio. Right? If you have 0 grams of fat, you don't have any, right? And then the data listed on the horizontal axis in the graph below, right? So if I look at this graph below, we have different trucks here, and then we're looking at vehicles sold in thousands. I guess they're not all trucks, right? A Toyota Camry's not a truck. So 5 top-selling vehicles, right? We just have some information on the top 5 selling vehicles and the number of vehicles that are sold. So the number of vehicles that are sold would be quantitative. And so this would be ratio. Right? So what we're doing is saying the data listed on the horizontal axis in the graph below, right? So the horizontal axis is this. So what we're looking at are these numbers. And if you notice, these numbers correspond to the number of vehicles sold in thousands, right? So notice that number shows you that. So that's why it's ratio, right? Because there is a natural zero and ratios make sense, right? All right, so that's all I have for the notes. There is just one other thing that I wanted to point out, and that is, I forgot to mention this. If we go back to thinking about qualitative versus quantitative variables, remember one thing I said, maybe like an easy test to think about is, does it make sense to add these together, determine if something's quantitative or not. However, sometimes you might have a qualitative variable and it does make sense to add them, right? Or it could provide something. So for example, if I added this column of female, I totaled this, I would get what? 1, 2, 3, 4, 5, 6, 7, right? That number is meaningful. And that number 7 is the total number of females I have in this data set, right? So in this case, it does make sense to add. However, these numbers are qualitative, right? These are splitting people into categories. So that was kind of my asterisk my disclaimer there when I said that it doesn't that test doesn't work all the time, right? I could also add first semester and add those together, and that total would tell me the total number of students that it is their first semester, right? Now, zip codes are qualitative also. It doesn't make sense for me to add zip codes together, right? Or like phone numbers. Those are qualitative, right? All right, so that's all I have. Let me know if you have any questions. Thanks.